coming from Faculty of Mechanical Engineering from University of Ljubljana. We just had 100 years of our university, and our laboratory was founded by Professor Novak, and I think our building is around 50 years old. It was one of the first buildings with the air conditioning, with the district heating, and yeah, we are building or preparing projects for new building because we have a lot of projects now and we are out of space in our existing building. I will be talking about the improved thermal storage for heating and cooling of the refurbished building. It is a European project. HEART is a holistic of energy architecture kit for multifamily buildings. And yeah, our goal was, as you will be see, to increase the or to store the solar energy from photovoltaic in the thermal accumulator. So I will just briefly go with this, let's say, introduction word. So we know that 40% of energy in EU is used for heating and cooling, and the important part of this energy is used in the building. And we also have a European directive, that's EPBD, and we have to, so in this directive we have goals to, to increase the share of renewable energies and also regarding the energy efficiencies. So this will be also translated to our Slovenian regulation very soon. There are also other goals, but I will not go into detail. I will go to the concept of the HEART. So this concept is prepared or shown here. You can see that the buildings will have the photovoltaics in the roof. With this photovoltaics will of course produce the electricity, and one part of the electricity will be stored in the accumulators, but the other part will be run by a DC heat pump, and the energy will be stored as heat or cold in the storages. So this is the idea, because we can store the energy very efficiently also as heat and cold for heating and cooling of the building. And of course we'll also have, we'll use the pipelines in the blocks where we'll distribute the water, and in the apartments we'll also have a small heat pump where we will use this, let's say, energy, but I will explain this later. You can see the other components of our systems, so the PV, the controller, the heat pump, the cold and hot storage tank. So this is our, let's say, work in this project. We also have a battery, fan coil, building energy management system, and decision support system. So those are work packages in our projects. So you can see the work package 1, which is the operation, and work package 2 is regarding the potential of the buildings which can be refurbished. Then we will have work package 4, which is connected to the cloud. But I will go just to work package 6, where our, let's say, storage is focused, and other work packages you can see after that. Some data about the building blocks. So we know that we have a lot of buildings which must be refurbished in terms of reducing the energy use. I will not go into detail. This is one of the work packages here. I will talk about the thermal energy system. We are using latent phase change materials. So if you compare it with a sensible, we know that if we have a sensible storage, water storage, the temperature of the water is increasing. But when we have a phase change material, it means that we use the material which change the aggregate state from liquid to solid and from solid to liquid. So the idea is to use such balls which I have here. So there, in this we have phase change material, and with these balls we'll increase the accumulation of the ordinary water storages. So this is the idea, just to use them as they are, and to put the balls inside and to increase the accumulation of the storages. These are some details. If you will be interested, we can talk about in the below. You can see the DSC curves for this material. We have some histories between melting and solidification, but this is not very important. And also here at the top, you can see that the system is connected to the heating system with the heat exchanger, because in reality they have some problems that the material with the leakage, and it must not come in the system, in the heating system. So that's why we have a heat exchanger in between, and we also want to do it in the real, because in the project we'll refurbish 2 buildings, one in Italy and one in France with this system. I will present you 2 experiments here. The first experiment was, let's say, the prototype, the school or student system. Here we have used the bottles. We filled it with the phase change material. Temperature was 27. You can see the capacity was 250 kilojoules per kilogram, and we have measured it. Here you can see some results. We have increased the accumulation with some numbers which have been not very high, because if you have low temperature difference, the melting heat will be higher. In this case, the temperature difference was quite high, and that's why this goal was, or the effect was not so high. But the important thing was we also have compared the experimental result with the simulation. So we have a transit model, or the program, where we have compared the experiment with the simulation. So the simulation, the model have been produced or made by technical use in University of Graz. The second experiment was, let's say, a real one. So we have used these balls. We have used 192 models. We have integrated them in the accumulator. So we have used 100 liters of volume, and 40% of the volume was PCM. Our idea was to test those thermal storages as a batteries, so we have made 3 of them, and in this experiment you will see the, let's say, middle results, where we have connected them in series. So you can make it like a batteries, so in parallel or a series, it depends on what you have or what you want. So here are the results for melting. So we cool down the water. So we come with the water, the temperature you can see, and we cool down. And in the other slides you can see the solidification. So we come with just the opposite. Those are preliminary results. So because the project is in halfway, so we have done 2 years, and 2 years will also have been done. Will be done. So maybe in the next Congress we'll give you more information about the results. Just for conclusion, some ideas. So there is a lot of, so the market for renovation of the buildings, the old buildings, is quite high. The latent thermal energy storage can be used for the accumulation of the energy for heating and cooling. We come to the 52% of higher energy density. We would like to have it higher, so we will try to improve it. And two, let's say for me, very important messages. So thermal energy storage with PCM represent a sustainable solution for storage of solar energy in the form of thermal energy with the use of heat pumps for heating and cooling of the building. This is one. And the second one, which is, I think, important as well. So thermal energy storage are, in comparison with the electrical energy storage, first cheaper, let's say 10 or more times cheaper per kilowatt hour, and you can use them longer. So also water storage and those materials are tested more than 10,000 cycles. So if you know that 1 year has 100 years of, but we don't heat or we don't use it. So this is for, I think, for long duration of the building, and but we know that the batteries we are using are lasting maybe for 10 years, and this is one of the, let's say, important goals of the systems which we are investigating now. Thank you.